sense? Okay. All right. So today we're going to look at HVAC design. And just like last week, even though we're talking about HVAC design, I'm not going to actually talk about HVAC design.
What?
The HVAC design is very complicated, and that's why we have Dave and others. But the important thing to understand, just similar to lighting design, is architectural design influences most of what they do.
Really?
And how we can reduce the need for Dave and the need for Terry, we will be more energy conserving. So
I'm an energy hog. You don't want me.
So that's the gist of what we're... So far we've looked at comfort, which impacts all three disciplines.
Right.
And envelope, it's mainly us, architecturally, but then mechanical and electrical supplement our design. Lighting-wise, it's still, architecture plays a huge role. Like we talked about on last week, the PSALI technique. I don't know if any of you remember that. Permanent supplementary artificial lighting interiors technique as an approach to towards lighting design is to assume that for a certain depth of space, I will have daylight. So you start off with that assumption, and you design your lighting towards that. So that changes your controls, that changes your fixture, layout, design, everything. So it's a different way of doing the same thing. So anyways, so architecturally we have a huge role to play in lighting also. And then today we're going to look at how mechanical design-wise, how architecture has a huge role and influence. Okay?
Sure.
All right, before we get into that, I think we're going to go through some quick terminology, understanding of mechanical design. And so I'm going to start off with the V in the HVAC, which stands for ventilation. And interior air quality, I'm going to try to draw the conclusion that understanding interior air quality and trying to maintain interior air quality is very important to energy conservation. So, do you guys agree or disagree?
Agree.
And reason? Why do you agree?
As an engineer.
Why is interior air quality very important to energy conservation?
Accounts for about 20 to 30% of your load.
Correct. Which is through ventilation. That's our primary way of solving interior air quality issues.
At the peak condition.
At the peak condition. So we're going to discuss that in a little bit more detail and how that impacts energy conservation. So through design, to maintain interior air quality, through our design, there are 4 simple ways to maintain interior air quality. First one, obviously, the obvious one is to limit the pollution at the source. An example would be our copiers. If we close our walls, then exhaust that copiers out, we limit the pollution right at the source. Isolate unavoidable sources of pollution. For instance, if our building if it's a lab building, then you cannot avoid certain type of indoor air pollutants. So maybe isolating them, just like our photocopiers, is one way to solve this problem. And then the third way, this is the most often what we do, is provide adequate supply and filtering of fresh air. So as the common saying goes, solution to pollution is dilution. Dilution, not delusion.
The solution to pollution is dilution.
Oh.
So that's pretty much what we always do mechanically. We try to dilute the pollutants in the air by providing more fresh air.
Put some outdoor air in and kind of push out those odors continuously.
Continuously. So the result of that, the more outdoor air you bring in, the more energy consumption you have.
But the air is considered more fresh.
Correct. So there's a balance that needs to be had throughout the design. So it is important to understand, without having to do this, how can we avoid those things through design? So then, passively, you're reducing energy consumption. And then the last one, this is something that we have very limited control during the actual operation of the building, maintain the building equipment, building conditioning equipment, but we have a huge role during design by providing enough clearance so that they can actually go and maintain these things. So it is important to keep that in mind from indoor air quality. Yes, Kelly?
On the fresh air portion, isn't there a minimum that's regulated?
Yes.
Minimum amount of fresh air? So
Correct.
you can't completely offset that
Well,
with design.
Similar to using the windows for daylighting, put the controls on it to turn the lights off. On the mechanical side, you can put CO2 sensors in order to drive down the outdoor air. If you don't have a lot of people installing CO2 in your space, down to the minimum that is for the VOCs of the carpet. So the current ventilation codes are, part of it is by area, part of it is by occupants.
Right.
So you can reduce your CO2 of all the occupants down to the minimum of the area, which is like 0.06 CFM a square foot or something.
right. And that
Very,
area,
very minimal.
that area CFM per square feet is based on the assumption that we will have some
Carpet,
materials
paints,
that will
be expelling
automatically
VOCs.
always releasing volatile organic compounds.
Right.
But then if you reduce the VOCs of your finishes or your components, you can't use those new numbers. Or
Excuse me?
you can't use the actual VOC content of your components. You have
Ventilation code, ASHRAE, is the
Correct.
standard. The latest codes are adopting those ASHRAE standards that start with the area, a minimum amount of CFM per square foot per area, and then have an additional calc for the CFM per occupant. And if you're using CO2 sensors, my understanding is that, and my knowledge base is, I'm reducing the amount of outdoor air down to the minimum by area because VOCs don't come out as CO2. So I'm not sensing VOCs.
Mhm.
There are other things I could use to sense VOCs, more controls, reduce it down to nothing.
Right.
So how far do you
And
want to take it?
typically, we won't get into that level of
Right.
sophistication. Well, maybe we have to, and that's a question that we can
Right.
ask.
That's
And
the next one.
Tartesso Elementary School is one project that we actually have those controls and detection installed. And we'll talk about that in a second.
Yep.
So anyways, these four concepts to solve this problem. Three are passive solutions, and one is an active solution. So let's look at some common air pollutants. And again, most of us know this, but let's just have a quick refresher of what air pollutants and what their sources are. So I'm just going to go through some of these. Excess moisture, that is an air pollutant, and cooking, washing, and just exhaling. Those are the people are the common source of excess moisture.
Shower.
Showers, yes, and carbon dioxide, and also human respiration. Carbon monoxide, this is an interesting one. This is through incomplete combustion. So, all of our schools, when we have kilns and whatnot, those are all incomplete combustion.
If
So,
they're gas,
yep, and if
Natural
they're
gas.
gas, correct. And if they're not gas, and if they're coal or wood,
just electric sometimes, to kill.
it could be electric, true. If our furnaces are coal or wood, then we have hydrocarbons. But if not, it's carbon monoxide. And then if the source involves if the source or the particle involves some kind of sulfur, then sulfur oxide is the air pollutant. And then we probably typically don't get into this nitrous oxide because we don't have a very high temperature combustion. It's
Be in your boiler room, potentially.
potentially, but it's mostly in the industrial.
Very isolated, right?
Right. And then this is something that we often get into, mineral glass and fiber as an air pollutant through our insulation. We have insulation all over the place, acoustical, thermal insulation. So making sure that they don't get ripped and they don't get into the airstream
So
is
if it's in your
very
airstream
important.
in your plenum, make sure it's faced.
Correct. And another,
Fiber is isolated from the plenum.
here's a passive way we can solve this. Our ducts typically have liners in them, and those liners can get damaged,
Yeah.
and then fiber can get into the airstream. So one way to avoid duct liners, is to allow for bigger ducts. So I know Gary going. If you have bigger ducts, then you don't have to acoustically treat the liners on the ducts on the inside with liners. Is that a true statement?
I'm not an acoustician, but I think typically the liner is due for acoustical reasons. If you make it bigger, you potentially slow down the fan.
Correct.
The
And
bigger
it's
the
not as
duct,
loud.
doesn't have to work as hard to get through the smaller
Right.
opening. The bigger the opening, uses less horsepower, usually generates less noise.
Less noise. So if liner is used from an acoustical standpoint, we have another passive alternative to provide more room, which is, so we just have to balance all those.
Which also, the bigger the duct, then the smaller the horsepower, the smaller the draw of electricity.
Less energy consumption.
Consumption.
What,
But it takes real estate to make that happen.
Correct.
in the valley or in Arizona, isn't the one that you do the littlest dust, isn't that the big one for us to deal with? I mean, dust.
Yeah.
Because I mean, the EPA is cutting off funding for the valley, for Phoenix, or for Arizona, I guess, because of our uncontrollable amount of dust. So,
And we are typically a sealed building, and that's why going into an ICF wall or much better
Right.
sealed
but if we're going
walls.
to encourage natural ventilation,
Correct.
now we're encouraging
That's a huge
dirty
problem.
air that's
Yep.
inherent in Arizona.
Exactly. So we have to validate that. So that's why some of the hybrid technology is much better in Phoenix, rather than completely relying on passively cooling our buildings.
Right.
Maybe we introduce some technology and we take the free cooling without the dust by filtering it. So radon, I was surprised to learn that Arizona is in the low to medium radon exposure in the soil.
Midwest is
But
bad.
I don't know why we don't test this in our projects.
We're cowboys.
Maybe it's not a big deal.
We don't care.
So that's another problem. VOC is something that we're all used to, the paints and different finished materials. And ozone, O3, is from photocopiers and printers. So that's the reason why LEED has an indoor chemical pollutant source control credit to block off all those things. Methane. This is from if we have a leaking sewage, or if we have some kind of garbage that we don't.
Or a cow.
Or a cow.
Biofuel,
Yes, if you have
those
biofuel.
energy systems.
So we have to make sure that this doesn't get into the airstream. And then pesticides. I don't know. We don't get into this a whole lot. But pesticide residues are a problem. So when we treat our buildings, we just got to make sure that they don't get into the airstream through some openings in the floor. It's typically in the floor. And the last one, dampness. So that's another big problem. If we have a lot of moisture, fungus will be an issue. Each of these pollutants have their have respective issues. We have respective issues with them, with eye irritation, lung issues with the lung, and so many problems. I'm not going to go into that. But it's best to avoid all these things as much as possible passively. And that starts with design.
I'm more comfortable if I don't have those.
Right. You
I
will
mean,
feel
it's my
more
comfort,
comfortable.
My indoor air
They
quality.
filled the whole sheet. There's no fresh air up there.